Okay, so the second part of this tutorial, I will show some illustration of comparison of a solution using analytical method and numerical method. So, yeah, from the equation, from this equation, this is the solution of the differential equation. Okay, so let me show again. The original equation is here. Okay, so let me go to new script. So first choose sample time ts equal to 0.4, and then you create a vector of time t take from 0 with the increment of ts until the final time, which is 4 seconds, and then I transpose this. If you want to know what this means, you can just copy and paste here. Okay, let me give ts equal to 0.4 first, and then paste again. So this is what it means. You generate time, and then you want to compute analytical solution. Okay. H equal to, so this is H analytical. Okay, just like this, equal to 5/2 times 1 minus exponential of -2 times t. Okay, so now you have t and you have H analytical. If you want to verify this, you can plot first to make sure that this is okay. Let me save. Analytical versus numerical. Okay, so just from this equation you can have this graph. Okay, and because you compute with sample time like this, you can have just actually you can get just a bunch of points. So to illustrate that, actually you have those points. I add it in the plot like this. Okay, and run again. Here just a bunch of points, and if you want it to draw to connect from one point to another, then you can make like this. Okay, now you want to compute H from numerical method, which is you can either use this formulation, because this one is simple problem. You can have a closed form or explicit form of the H of k, right? But you can immediately apply. I mean, you program to recursively compute hk using this equation. Okay, both ways are fine. Because most of the case, especially when you have nonlinear equation, you can only use this way. So I will show you this way. And because this you need to compute it recursively, you need to use a loop. Okay, so for I take from 1 up to the length of t minus 1 y. So what is length of t? Length of t is here 1 2 3 4 5 6 7 8 9 10 11. Okay, 11 points. So length of t is 11. You can verify it. Length of t is 11. So oh, we don't need to use this. So I use take up to from 1 up to 10 because I will use index I plus 1. So when I is 10, then I plus 1 is 11 because the terminal point is like that. So I can write, well, hk I plus 1 equal to hk of I. Why don't I just use h and index k? So you don't need to, yeah, I use index k, and here I don't need to use k there, but just k here directly, right? Yeah, I can use this one, hk. Oh, here I use k minus 1, huh? K minus 1. So yeah, so I should start from 2 and add the length like this. So I use here is k and here is k minus 1. Okay, yeah, that is a lot of trick. And plus here I can have minus 2 times h of k minus 1 and plus 5 and all time ts. Okay, right. But here I need to access the previous value of h, but I don't have any h before. How can I run this? I don't have h before, so the first you need to allocate memory for h, allocate memory and put all the values 0, which means you can just say h equal to 0. First you put all 0 element in there. Okay, okay, length of t is 11, and yeah, like this. So what does this mean? You can copy it and paste in here. Okay, enter. So it means you allocate memory and put all the values 0 to the 8 first. Later you compute, start from 2. It means you start from here. That the computation need to use this value, and then when k go up one more step, you compute this, and you need value in this memory, right? So it's recursively like that. Okay. Yeah, because we start from 0, right? So start from 0, it means this one is already correct. The first one is already correct, right? So if you are unsure, I mean, if in other case the first element is not 0, then you can just change here, right? If you start not from 0, then you just change 0 here to be some value. All right, so I just want to give you the overall format. And when you want to plot together, so you have analytical, and then you have h here, which is obtained from numerical method. Yeah, here you can see it. And you want to change axis to have a uh, clear curve. Yeah, just axis. You take from 0 to 2.1, maybe for t 0 to 4 seconds, and then for h vertical axis is from 0 up to 3. Okay. And you want to have a grid to see the grid, just put grid on. Okay. So now I want to plot another h that I choose different sample time. Okay. I want to choose different sample time. So I use another h. Actually very similar to this, but you need to generate different time with vector of time. So let's say, well, I want to simulate another case that Ts is smaller, let's say 0.01. I want to know whether 0.01 Ts, with this value, the numerical solution is close enough to the analytical solution or not. Okay, so I generate another T1, which is I can copy here and put here. Yeah, just put T1 here. Yeah, maybe if you want, you still want to use TL later, you just use TS1 like this. Okay, and then you can copy this and you just change. Okay, H to H1 and T to T1. H1, okay, it's not a problem. T1, H1, 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 TS1. Okay, in this way it's better, it's easier. And you want to plot together, no way, you cannot plot together because of the dimension. But well, maybe you can do this. You put another T1 and another H1. Let me try. Yeah, so maybe 0.01 is to, yeah, actually if you look at the point here, you can see that it's close enough to the yellow one, the blue. You can see the blue, but because from one point to another point of the analytical solution, you just connect it in a straight line. So it looks like it's a little bit far away from each other, right? But actually you carefully checked. Um, Maybe I put the star. Yeah, I put the star for the blue one, right? I put the star for the blue one. I guess. Oh, actually, we can put here as well. Yeah. Oops. Yeah, sorry. Yeah, like this. You can see you checked. You check the point of the blue point and the yellow is very close together, right? So this means if you choose TS 0.01, you can represent the solution from that to be analytical solution. It's very, very close to analytical solution. Okay. And this one, the red one, represent discrete system, a discrete equation that you obtain from the approximation. Yeah, with considerably large sample time, right? So 0.4, it is actually large sample time. All right. So actually here I'm using Euler method, right? Um, so next part, I want to show you how you can use Euler method in Simulink. So let me go to Simulink. Yeah, a little bit long. Yeah, so here it is. Oh, I can start from file. Yeah, I create another file and initialize. Uh, yeah, I can initialize this. Control C for analytical, and then I can call Simulink. I can call Simulink. Let's call it first order. First ODE dot SLH. Okay, so now I already have Simulink. Can open up a library to add some block. Yeah, so first I create right hand side of the differential equation. Right hand side, so I can use MATLAB function. It's not search like this. MATLAB function. Okay, Simulink user defined function. Press on space to fit the screen. Zoom in a little bit, or zoom out. Now I change the name is right hand side. Okay, so you can easily recognize it. What is the right hand side of the equation? The right hand side is minus 2h plus 5, right? I can see here, or I can see here. Yeah, I call it right hand side. If I move, yeah, let me rewrite equation. H dot equal to minus 2h plus 5. Okay. So here is right hand side. So right hand side, the output, I just call it H dot, and input is you can say U and H. What is U? UH actually is just 5, right? Um, yeah. So I can write here H dot equal to minus 2 times H and plus U. U is just 5. Okay. Let me sell this. Analytical versus numerical. Oh, I sell the name different from this. This is wrong name. I should, yeah. But first, let me finish this. I will explain it later. So I say U is 5. So I put a constant here as 5. And because I have H dot, I need integrator. Okay. Once I have H dot and integrate it, then I can have here is H, right? So if here is H, you need to use here as well. Okay. And then I want Simulink to send data to workspace. Okay, I can use out Simulink port subsystem out 1. And if you put it, the name here is H, it will send the data to the workspace name as H, right? So this Simulink has output. Yeah, this Simulink has output. Now I'm going to choose Euler method. So I need to go to model setting. Yeah, model setting. And then I choose here, here solver. I choose fixed step. And then I can choose ODE1, ordinary differential equation, first order, Euler. Okay. And then I put the sample time because I already run TS in the main file, TS, so I just put TS here. And the final time, I can put it 4 seconds as well, right? Then okay. Let me memorize the name, analyze versus numerical, underscore Simulink. Yes, sim. So I should change name here to be the same. So analyze. Yeah, actually in Simulink is numerical already. Versus numerical underscore sim. So because this Simulink has output here, H. It has output H here. So I can write H equal here. Okay. And then now I have H and O. I also want time from Simulink. No, I don't need because I have time here. Right, I have time here. Yeah. So let me sell first. and I use this one with 1. Then I can plot, maybe I can copy from here, plot, or maybe no need, I should try to, so that you can easily follow, right? So I plot time with each analytical method, and then each. Okay. Let me run first. Maybe there is one mistake. Can it run? No, it cannot run. No system file call Simulink. Oh, yeah, without a, and let me run. No file name this again. Oh no, this one. Dimension, maybe dimension is not right. Let me check length of h. Length of h is not right, maybe. Just one. Oh, okay, I see. So just one. It needed only sell the last number. So I need to use my own method, which is to change this one to workspace. And I name it H like this, and change from time series to array, from 3D array to 2D array. Okay. And then you don't need to use this H, because this one is going to give put into workspace with a variable H, something like that. But I need to run and check it first to check the name. Okay, so I command this, and then I run this, called Simulink, and run it complete, and then it's sell to workspace. Where is workspace? Here with the name H here, but the H here is, yeah, why it's so like this? So H here is not right, and oh, I see. Okay, why out here? Oh, H is not right, but answer, it give answer, and H is inside answer. I see. Yeah, let me clear out something so to avoid confusion. Let me clear all variable. Let me clear all. Yeah, so you don't have H. Well, I run this one again. It's okay, and then you look at the workspace. You can see answer. You don't see H. Actually, in the Simulink here, I put the name H, right? I put the name H. But when it store the variable in the workspace, it just answer. But if you go into here, you can see H inside. Okay, actually H is there. So what you can do now here, you cannot use H like this. Instead, you use answer.h. Okay, yeah, and then I want it to put the marker like this, and let me run again. Yeah, here it is. And you want axis to be like this one, Control C, Control V. Okay. Yeah. Then what if I want to have I want to simulate the same way as before, but I use a different sample time in here. Okay, I use different sample time in here. So well, maybe I can just change sample time here 0.01. Okay, and then I can run here. Yeah, yeah. So you can see that the numerical solution and analytical solution almost overlap, right? Almost overlap, the red and the blue. Okay. Yes. And what happens if I choose TS too big? Let's say I use 0.5001. What happened? It's still stable. It's still stable, huh? Okay. Okay. What if I change the final time up to, uh, let's say 50, let's say 40, and I choose this one is 0.7. Error. So. What happened? 0.7 TS here, TS here. Oh, I see. I think maybe one. Okay, the difference is length of T is this, and length of answer dot x. Oops. Sorry, let me run again. Even are not consistent. Length of T is 58. How about answer dot x? Oh, I see. Answer here. Um, well, run again. Okay. N or length of T 58, and then length of answer dot H only 6. Why only 6? So Simulink stopped. Oh, not stop here and 40 here. I see. This is the mistake. Yeah, 40 here, same here. I see. Okay, run again. Yeah. So look at here. If sample time is so big, fortunately this is still stable. But if you are not lucky, the red one can explode. I mean, it's not stable. sometimes it can be numerically unstable. For this one, it's still stable, so yeah, it's still fine. But you can see that the gap between solution of numerical method and solution of analytical method become far away. Okay, become big when TS is too big. What about Rangata 4? If I choose Rangata 4, what happened with large sample time? So let me go to model setting, and then I choose Rangata 4, ODE 4. It uses 4 order, right? So what happened? Interestingly, even though sample time is big, the solution from numerical method and the analytical method are almost same, right? So actually, when you choose Rangata, most of the time you consider it as a solution of the continuous equation because it's very accurate compared to Euler. So if you want to use Euler, please be careful with the sample time. Okay. All right. Is there any question? Yeah. Right hand side. This one. Here. So this is right hand side. Yeah, you just compute it to get some numerical value, right? And for this one, you can name it anything. The main point is that you want to compute all the right hand sides and give it to the output here from here. Oh, by the way, I forgot to tell you one thing. Where initial condition you need to put? I did not mention, right? Actually, you put in the integrator. So integrator implement Euler method when we choose Euler, right? So actually the numerical method is in here, in this integrator. And here is initial condition. Fortunately, it's the default value is 0. For some cases, initial value is not 0. For example, I will give another example with this one with second order like this one, and it's nonlinear, right? This equation. Now, so let me build another Simulink for that equation. So I just copy this. Okay. So you still can have the same structure for the Simulink, and now you don't have input. You put 0, and for the right hand side, let me show you about the initial condition first. Simulink. Yeah. So yeah, initial condition theta 0 is pi over 3, theta dot 0 is 0. So you put initial condition here to make sure that you do not forget it. So pi over 3 is h1, right? And then 0 is h2, correct? Yeah. H dot is theta dot is h2. Okay. Theta is pi over 3. And then right hand side, for right hand side, because uh, you have two two elements, so you initialize h dot 2 1 equal to 0 0 first, yeah, or yeah, and then h dot of 1 equal to h2, okay, and then h dot of 2 equal to minus g minus g, let's say, yeah, I should give here, yeah, g is 9.81 and L equal to, let's say, 2 meter. So here is g divided by L and time sine h1. See, it has yellow. Why h dot h dot h? What is this? Yeah, u is 0 already. We don't use it, right? So I can run this one, and then I can have now h is something else. Oh, I have h and h1, I think. Let me see Simulink again. Yeah, I have h and h1. So I can plot t and answer dot h1. Yeah. So this one is the result for this model. Okay. So this is not good. The sampling time is too big, right? Sampling time too big. So I can change the sampling time to oh no, I don't need to change here. I can just change here. Let's say 0, oh, just 0 1. Yeah, so this is better, right? So this oscillation from the equation of pendulum, and we have h1 and h2. h1 is theta, which is angle, the measurement or the value of angle, and the red one here is theta dot, the velocity, because from this equation we say h2 is theta dot. So any more question? Yeah, for the first example, you can see that the red and the blue overlap. Cannot distinguish between the two. But how can I know that there are two in here? I can view the legend. Where is legend? Insert legend. So there are two data here. Yeah. Okay. So we can run two models in parallel together with Simulink. It's easy to build, right? You don't even care about the order or something. Okay. Yeah, you can just draw the block anywhere you want. And you have the same format. MATLAB function, write all the right hand side equation, and then you put one integrator and just put the right initial condition. It's done. Okay, very easy for uh, when you are using Simulink, right? You program it by yourself, a little bit troublesome, right? So when you practice next time, just want you to create your own like function, and then you call algorithm of Euler, and then you don't write on the same file, but you just call function. I mean, for example, you create one function like Euler method. No matter what function you have, you can still use this function. Okay, I mean, make a proper structure. Um, not just follow what I'm doing, because I will go check one by one to make sure you can create your own function and can call several functions, okay, to the main file, to the main file. And I want you to be more familiar with Simulink, because in the practice number 2, you will build Simulink to control an actual DC motor. Okay, after you learn how to design controller, right, and then implement the controller to the real hardware, real system. Okay, so try to get familiar with Simulink as much as you can. All right, so I stop now.